The active ingredient is called hydrated silica. It is a fine abrasive compound found in almost every tube of toothpaste on the planet, and it costs about $1. Apply it to a foggy, yellowed headlight, and it physically polishes away the oxidized layer of degraded polycarbonate that is blocking your light output. Controlled tests by automotive hobbyists and consumer labs showed 30 to 50% improvement in light transmission on moderately oxidized head lenses from a single application. The U.S. Department of Transportation has noted that degraded headlights can reduce light output by up to 80%, which is a genuine safety issue that affects millions of drivers every night. Here is the part the automotive detailing industry does not advertise. Hydrated silica, the compound doing the actual work, is sitting in a tube in your bathroom cabinet right now. The $30 to $80 headlight restoration kits sold at auto parts stores use higher grit versions of the same abrasive polishing chemistry. The professional headlight restoration service, charging $50 to $150 per pair, uses the same mechanism with better graded compounds and a UV sealant at the end. The abrasive polishing step is the same science whether it costs $1 or $80. What you are actually paying for in the expensive versions is the UV protective coating at the end, which is the genuinely important part that most people skip entirely. This is Mike's Raw Knowledge, and today we talk about what is actually inside your headlights, why they fail, and what the chemistry of restoring them actually is. To understand why headlights go foggy, you need to understand a decision the auto industry made in the 1980s that changed every car on the road. Before the mid-1980s, automotive headlights were made of glass. Sealed beam glass headlights were standardized across the American auto industry from the 1940s onward. Glass headlights had problems. They were heavy. They were fragile in minor impacts. They limited aerodynamic design because sealed beam units came in fixed shapes, and they were expensive to replace when broken. So, when polycarbonate plastic technology matured enough to be used for headlight lenses in the 1980s, the auto industry adopted it enthusiastically. Polycarbonate was lighter, impact-resistant, and could be molded into any shape a designer wanted. The problem that nobody talked about in the initial excitement was that polycarbonate is vulnerable to ultraviolet radiation in a way that glass is not. Glass is essentially UV opaque. Polycarbonate is not. When UV rays hit polycarbonate plastic over months and years of outdoor exposure, they break down the protective clear coat that manufacturers apply to the surface of the lens and then begin degrading the polycarbonate itself. The surface oxidizes, yellows, and develops a network of microscopic cracks and pits that scatter light rather than transmitting it cleanly. The clarity that made the headlight effective when new is gone, replaced by a diffuse yellowed haze that blocks a significant portion of the light the bulb is trying to project. Manufacturers knew about UV degradation of polycarbonate when they made the switch. The solution was a UV-resistant protective clear coat applied to the lens surface during manufacturing. The clear coat works well when it is intact. The issue is that it does not last forever. Road debris abrades it. Chemical exposure degrades it. UV radiation itself eventually breaks it down from the outside in. After enough years of exposure, the clear coat fails, and the degradation of the polycarbonate beneath it accelerates quickly. Here is where the economics become interesting. A glass headlight that became scratched or damaged needed replacement. That replacement was expensive and generated revenue for the parts industry. A polycarbonate headlight that clouds over does not necessarily need replacement. The lens is still structurally sound. The polycarbonate is still intact. What has failed is the surface layer. An abrasive compound that polishes away the degraded surface layer and a UV sealant that replaces the protective coating restores the lens to near original clarity for a fraction of the replacement cost. The headlight restoration kit market, which generates tens of millions of dollars annually, was built on that premise. But the underlying abrasive chemistry that does the polishing has been in toothpaste tubes since the compound was first developed, costing almost nothing per application. Everything on this channel is about the same pattern, a compound with real documented chemistry that the industry knows about, uses, and sells back to you at a significant markup while the raw form sits in plain packaging costing almost nothing. Hydrated silica, zinc sulfate, oxalic acid, tannic acid, acrylic copolymer resin. The list keeps going. Subscribe so you catch every vault we open. Here is the actual chemistry of what happens to polycarbonate headlights over time and why abrasive polishing restores them. Modern headlight lenses are manufactured from polycarbonate plastic because of its impact resistance and lightweight. During manufacturing, a thin UV-resistant clear coat is applied to the exterior surface of the lens. This coating is the headlight's primary protection against UV degradation, and it is the first thing to fail. When the clear coat begins to break down, UV radiation reaches the polycarbonate surface directly and initiates photooxidation, a process where UV energy causes chemical bonds in the polycarbonate polymer chains to break and reform in degraded configurations. The surface develops a layer of degraded, oxidized polycarbonate that is visually opaque, yellowish in color, and microscopically rough. Light passing through this degraded layer is scattered in multiple directions instead of being focused and transmitted cleanly, which is why a yellowed headlight produces a dim, diffuse beam instead of a sharp, bright one. Hydrated silica is a fine abrasive compound specifically designed to polish surfaces by mechanically removing thin layers of material through controlled friction. In toothpaste, it is calibrated to be abrasive enough to remove plaque and surface stains from tooth enamel without damaging the enamel itself. Applied to a polycarbonate headlight surface, it physically removes the degraded outer layer of oxidized polycarbonate, exposing the clearer, less degraded material beneath. Consumer lab-controlled tests showed 30 to 50% improvement in light transmission on moderately oxidized lenses from toothpaste-based polishing. For lenses with heavy deep oxidation, the improvement was more limited because the degradation extends beyond the depth that surface polishing can reach. Here is the honest and critical part that most discussions of this topic skip entirely. Polishing with hydrated silica restores clarity by removing degraded material, but it does not replace the UV-resistant coating that was protecting the lens. Without reapplication of a UV-resistant sealant after polishing, the freshly exposed polycarbonate surface is essentially unprotected and will begin reoxidizing under UV exposure within weeks to months. This is why toothpaste results fade quickly when used alone. The polishing step works. The missing step is the UV protection afterward. A UV-resistant automotive clear coat, or even a carefully applied layer of UV protective sealant applied after polishing, extends the result from weeks to months or years. That combination, abrasive polish plus UV protection, is exactly what the commercial restoration kits provide. The abrasive chemistry is the cheap part. The UV protection is the part that makes the result last. The global automotive aftermarket is a massive industry, and headlight restoration sits within it as a consistently growing segment. Professional headlight restoration services charge between $50 and $150 per pair of headlights in the United States. Headlight replacement, when a lens is deemed too far gone for restoration, runs from $130 to over $1,000 per headlight, depending on the vehicle. With luxury and newer vehicles running toward the higher end because of integrated sensor and camera systems built into modern headlight assemblies. The commercial headlight restoration kit market generates tens of millions of dollars, annually selling products whose core active ingredient is an abrasive polishing compound. The same fundamental chemistry as hydrated silica in toothpaste, bundled with sandpaper in progressively finer grits, a polishing solution, and a UV sealant. The UV sealant is the genuinely valuable component because it is what protects the restored surface from reoxidizing quickly. The polishing chemistry itself is commodity chemistry available in every bathroom in every home in the country. The auto industry's original decision to switch from glass to polycarbonate created the headlight degradation market by design. Not intentionally designed to fail in a conspiratorial sense, but structurally designed in a way where the cheaper, lighter, more aerodynamic material choice had a known degradation timeline that would generate aftermarket revenue. Glass headlights do not oxidize. Polycarbonate headlights do reliably on every vehicle after enough years of UV exposure. The aftermarket for restoration products, replacement lenses, and professional services was built into the material choice from the moment the industry adopted polycarbonate in the 1980s. The auto industry switched from glass to polycarbonate headlights in the 1980s, knowing that polycarbonate degrades under UV exposure and knowing that the protective clear coat applied during manufacturing has a finite lifespan. The degradation is real. It affects millions of vehicles, and the Department of Transportation has acknowledged that foggy headlights represent a genuine safety issue by reducing light output by up to 80% on severely degraded lenses. The compound that polishes away the degraded surface layer is called hydrated silica. It is in almost every tube of toothpaste on the market, and it costs about $1. The part that makes restoration last is UV protection applied after polishing, which is cheap and widely available. The auto detailing industry built a restoration service and product market on top of this chemistry. The replacement lens industry built a higher margin business on consumers who did not know restoration was possible. The vehicle manufacturers built polycarbonate into every headlight, knowing glass would never have created this market at all. The name of the active ingredient is hydrated silica. The critical missing step that most people skip is UV protection afterward. Now you know both. Everything in this video is for educational purposes only. Results vary based on the degree of headlight oxidation and the products used. Severely degraded headlights may require professional restoration or replacement. Never compromise vehicle safety by driving with inadequate lighting. Mike's raw knowledge is not responsible for outcomes from applying any information discussed here. Subscribe. Share this with every driver you know whose headlights have been slowly going dark.